Did I? Iram,
Yes.
a lot of noise, please.
Yeah, like there's no noise here. 1 minute, sir.
Okay, did I teach you principal superposition of electric field?
Yeah, you did.
Okay, look, let me remind you. Let it be P is a point, Q1, Q2, Q3, up to Qn. These are the charges. Now, if we have to calculate the electric field due to all charges, so what do? We calculate the electric field due to Q1, then due to Q2, and just do the vector sum of all the electric fields to calculate the net electric field at point P. Hmm. Just a minute. This is a question based on principal superposition of electric field. Try to do it. Try this question. The 2-point charges Q1 and Q2 10 to the minus 8 coulomb and minus 10 to the minus 8 coulomb respectively are placed 0.1 meter apart. Calculate the electric field at point A, B, and C. Now, let me tell you how to do it. So, I'll show you electric field at one of the point. Let it be A. If we have to calculate the net electric field at point A, so due to a point electric field due to a point charge is given by KQ over R square. Now this formula we have to use it. So now due to plus 10 to the minus 8 coulomb, that direction of the electric field is towards right, because as I told you, the direction of electric field due to positive charge is always away from it, and due to negative charge towards it. So first of all, we will calculate the electric field due to this positive charge at point A. So let it be E1. So E1 equals to K is 9 into 10 to the 9. Charge is 10 to the minus 8 coulomb over the distance is 0.05 square towards right. Towards right. Solve it. 9 into 10 to the 9. 9 into 10 to the 9 into 10 to the minus 8 over 0.05 into 0.05. No. 9 into 10 to the 9 minus 8 10 to the 4 over 25. If you solve it, you'll get 9 into, this is 4 minus 4, minus 4, 5 over 25. If you divide it, so 900 divided by 25 tends to our 3. Divide 900. If you divide 900 by 25, how much will you get it? That is Newton per coulomb. So right here, 5, 5, 5, 5 is 25, 5, 8, 180. If you divide it, 3 is 50, 5, 6, 36 tens to the 3. You can write 3.6 tens to the minus 10 to the 4 Newton per coulomb. Coulomb towards right. Like way. Likewise, if we have to calculate now, we will calculate similarly due to negative charge. So let it be E2. That is again because the charge is same and the distance will be same. So the magnitude will be same, 3.6 10 to our 4 Newton per Coulomb towards left. Now due to negative charge, the direction will be towards right, sorry. Towards right. I repeat, the electric field due to a point charge formula, we have to apply it. First of all, we will calculate due to positive charge. So the direction will be towards right because as I told you, that due to positive charge, the electric field is away from it and due to negative charge towards it. So it is a positive charge. Now we have to calculate the electric field at point A. So the direction will be towards right. Now due to this negative charge, so the direction will be towards the negative charge. It means again towards right. Now both the electric fields have the same direction. Hence, electric field at A equals to E1 plus E2 towards right. Now 3.6 into 10 to the power 4 plus 3.6 into 10 to the power 4, 7.2 into 10 to the power 4 Newton per Coulomb towards right. Understood?
Yeah.
Good. Similarly, let me know the answer. Try at B. Fast theorem. And if you don't get it, please let me know. I'll let you know how to do it.
So I did not write the question. Can you just show me the question?
Good. Do you know how to do it? You don't follow the same methodology. Now we have to calculate at point B. So due to this positive charge, the direction will be towards left, and due to this negative charge towards right. First, distance will be different. Due to negative charge, the distance will be 0.5 plus 0.5 plus 0.5. All right. And once you're done, please let me know. We will proceed. Are you getting Iram, or shall I do for you? Iram, am I audible?
Yes, sir. I'm
Will
doing.
you done? Now at B, the distance at B will be, sorry, the electric field at B.
It. 3.2 into 10 power 4. So you mute.
Sorry. Now we have to subtract from the electric field due to positive charge. Fine. What is the total distance from the negative charge? 0.5 plus 0.5 plus 0.5. How much? I think 0.15 whole square. So 9 into 10 to the power 9 into 10 to the power minus 8. 0.05 square minus 0.0.15, and net field towards left. Now calculate 990 0.0 0.15 square minus 0.05 square over 0.0 square 0.15 square. Now solve it. 0.A plus B is 0.15 minus 0.5 over 0.05 whole square 0.15 left. It would be 0.2, and this is minus 0.1. Iram, how much will you get it? 3 point.
3.2 into 10 power 4 Newton per gram.
Are you sure?
Yeah.
Let me check. Give me a minute. Let me check the answer. Okay, answer is correct. 3.2 times 1 minus, so 3.2 times 4 Newton per Coulomb towards left. Towards left. Moreover, will you be able to calculate at C? How to calculate
Yeah,
at?
let me try.
We have to use the vector law of addition. Daniram. First of all, we will calculate due to U1, then E2, then you have to apply the vector law of addition. That is, so E equals to E1 square plus E2 square plus 2 E1 E2 cos 120. Okay, this is the way, this formula you have to apply to calculate the electric field at C. Is it fine? Shall we proceed?
Yeah.
Now this question, try at home. Find the magnitude and the direction of electric field. Just a minute, Iram. Mark the questions in assignment electric field due to a point charge. First question. Second question. Third question. This one. Question number 6. Okay, all 6 questions you have to do it from this assignment. Did you mark?
Yeah.
Okay, fine. This one more question. Find the magnitude and the direction of the electric field at point P in figure 1.53. This is the figure. In this question, we have to calculate the electric field at point P. Look, if it is A, it is A. So the by using Pythagoras, we can write root 2A, the total distance means AC is root 2A. Now, if we have to calculate the electric field at point B, now due to this positive charge, the distance is, so AP equals to PC, that is root 2 over 2A. Okay, the distance is same. Now, due to this positive charge, the electric field towards C, and due to this positive charge, the electric field towards A. So EC equals to EA. So net field due to these, EC minus EA will come out equals to 0. Now we have to calculate the electric field at point P. Now, due to these two charges, which are located at point A and at point C, so the net electric field will come out to be 0. Now, what we have to calculate? Just we have to calculate the magnitude due to V at point P. That is equals to, at point P, the electric field will come out 1 over 4 epsilon Q. Now, the distance is, let it be R square. So how to calculate R? If it is A, this is perpendicular. This is root 2 over 2A. Again, we will apply in triangle PBC using Pythagoras. This is hypotenuse. So A square equals to R square plus root 2 over 2A whole square. So R square plus 2A square over 2A square, this is 4. So R square equals to 3A square over 4. Now what we need? R square. Just substitute the value 1 over 4 epsilon Q over 3A square over 4. Now 1 over 4 epsilon, so 4Q or 3A square along BP. We can write along BP because this is positive charge. Now the net electric field is 4 will cancel out if you simplify it. 3 pi epsilon A square along BP. This is electric field. Is it okay, Iram?
Yeah.
Means, did you understand the concept of electric field due to system of charges? Try
Yeah.
it. Try all the questions of assignment at home. in homework. Now, charge distribution. There are three types of charge distribution. First is linear charge distribution. It is defined as linear charge distribution. If it is a wire, let it be, it is the charge is uniformly distributed on it. Now, the linear charge distribution is also known as linear charge density. It is defined as, it is denoted by lambda. It is defined as charge per unit length. Fine. Its SI unit is coulomb per meter. Means lambda charge distribution gives you, means let it be a wire having length L. Now, what is the, how much charge is distributed over unit length is known as lambda. Fine. So linear charge density or distribution is defined as dq over dl, that is charge per unit length. Means the charge distributed over a unit length is defined, is known as linear charge density. Its SI unit is coulomb per meter. Surface charge distribution. It is defined as sigma charge per unit area. Fine. When do we take linear charge density? When it is a ring or line wire. When do we take surface charge density? Just a minute. Its SI unit is coulomb per meter square. Now, example is lamina. Lamina means rectangular sheet. Fine. Or hollow sphere. So while dealing with these continuous body, we have to take surface charge density. When we deal with the length or ring, means a straight wire or a ring, then we will take linear charge density. Wire or ring. Likewise, volume charge density, it is defined as, it is denoted by rho, it is defined as sigma, charge per unit volume. Its SI unit is coulomb per meter cube. Example, solid sphere. Fine. So whenever we deal with solid cone, solid sphere, we will take solid cone. We will take volume charge density. Did you understand all three charge distributions? Iram, is it okay till here?
Yeah.
Okay, fine. Now further. Now electric field due to a ring. This derivation is very important. Electric field due to uniformly charged ring at an axial point. Fine. So let it be a ring. Positive charge distributed on its length, having radius capital R. Now we have to calculate the electric field at point P due to this ring, making an angle theta with one of its element. So what do we have to calculate? To calculate electric field at P. Is it okay till here?
Yeah.
Now, what we do while dealing with this kind of stuff, it is a continuous body. Fine. As I told you, whenever we take a ring or a wire, we have to take linear charge density, that is lambda. So let it be the capital Q is the total charge accumulated on its circumference. Now, first of all, what we do, we have to assume an element. Fine, this is an element. Fine, having length dl and the charge on it is dq. Fine, so let it be lambda is the surface charge density dq over dl. So due to this small charge, the electric field at point P will be like this in this direction. Let it be due to this small charge, the electric field will be very small. That is dE, making an angle theta. This is and with the horizontal. Now, so the magnitude will be 1 over 4 epsilon dq over, let it be r. This is r square. Is it fine? So what we do? First of all, what we do, let it be a ring. Let it be the total charge, capital Q accumulated on its circumference. R is the radius of the ring. Now we have to calculate the electric field at point P due to this ring. Now, first of all, we will assume a small element having charge dq. So due to this dq, we will calculate the electric field at point P. So that would be dE. So dE equals to 1 over 4 epsilon dq over r square. Is it fine till here? Iram, is it okay till here?
Yeah.
So as I told you, lambda equals to dq over dl. That is also equals to, just a minute. Hello, Iram. Am I audible?
Yeah.
No. So lambda equals to dq over dl. That is also equals to total charge. What is the length of the ring?
2R.
2 pi r circumference. Okay, so lambda equals to dq over dl. That is equals to q over 2 pi r. 2 pi r is the length of the ring. Fine. Circumference is known as the length of the ring. Now, so now substitute the value 1 over dq is, so if you find out the value of dq, so q times dl over 2 pi r. Now substitute here. So q times dl over r square, this is 2 pi r. Okay, now further. So 1 over 4 epsilon q dl over, what is, okay, we will substitute eventually, r square 2 pi r. Now the total electric field. Now, if I, moreover, look here, if I assume due to the symmetry, if I assume the same element here, so electric field will be in this direction. All right, making an angle theta due to the symmetry. So there are the two components. If it is theta, it would be theta, it would be theta. Okay, Ram. Now resolve it. It would be dE sine theta. It would be dE sine theta. It would be dE cos theta and dE cos theta. All right. Fine. Due to the symmetry, if I assume an element at the below of the ring, so you'll get the electric field, small electric field will be in this direction, making an angle theta. And if I resolve it, so we will get dE sine theta perpendicular components, and dE cos theta along the horizontal direction. All right. Okay, Iram, shall I move further? Iram, all right. Do you have any doubt?
No, sir, I'm just noting this.
Okay. Now further. Here, perpendicular components will be cancelled out. Hence, net field at P will be DEX, that is DE cos theta. Now substitute the value. So DE equals to, this is equals to 1 over 4 epsilon QDL for R square 2 pi R. And what is cos theta? Cos theta is X over R. This is equals to 1 over 4 epsilon Q DL times X over R cube 2 pi R. Do you have any doubt till here? This derivation is very important.
No.
Now further, this is DE, X, net electric field. So the next net electric field, total electric field, sorry, equals to, we have to integrate X over R cube 2 pi R. Now 1 over 4 epsilon is constant, Q is constant, R cube is also constant, X is also constant, 2 pi R is also constant. Now we have to integrate DL. Now if I integrate DL, what will you get, Iram? If I integrate, what would we get? Integration of DL will be, if I integrate the length of the ring, what would you get, Iram?
Oh,
If I integrate, means if I integrate DL, that is the length, that is the small length, very, very small element of the ring. If I integrate it, what would you get? DL is the length. Okay, we have to integrate from 0 to 2 pi R. Okay, the integration will be 0 to 2 pi R. 1 over 4 epsilon qx over r cube into 2 pi r. And if we substitute 2 pi r, 2 pi r, 2 pi r will be cancelled out. So answer will be 1 over 4 epsilon q over r cube times x. This is the net field at point P. Okay. Done, Iram?
1 minute, sir.
Do you have any doubt?
No.
Okay.
So just let me note it.
Shall I shall I move further? Iram, shall I proceed?
Yes, sir.
Okay, fine. Now, what is the value of R? R is basically x square plus R square. Fine. So the net field equals to, it would be x square plus R square raised to 3 over 4. All right. This is the net field due to a ring. Now, further, if x is 0, it means the electric field at the center. So EP will come out equals to 0. Fine. Second, if x is much greater than R, means the radius of the ring, so electric field would be 4 epsilon cube. We will ignore R square. It would be R cube, sorry, x cube, cancel out, 1 over q x square. Fine. This is exactly the same electric field due to a point charge, isn't it? Fine. So if the distance is much bigger, much greater than the radius of the ring, then this ring behaves like a point charge. In this, behaves like a point charge. Fine.
Yeah.
Do you have any doubt? I repeat this derivation. Now, electric field due to uniformly charged ring at an axial point. Fine. Let it be a ring. This is a ring having radius r. Q is the total charge accumulated on its circumference. Now we have to calculate the electric field at a distance x, point P, the distance x from the center of the ring. Now what we do first of all, we will assume a small element of the ring, that is dl, and we will assume the small charge dq is accumulated on this element. Now we will try to calculate the electric field at point P due to the small charge. So fine. We will try to calculate the small electric field due to the small charge at point P. That is, we will use the formula due to a point charge. That is 1 over 4 epsilon dq over r square. R is the distance from the element. That is hypotenuse. So 1 over 4 epsilon q. Now, we will try to find out the value of small dq in terms of L. So lambda equals to, this is linear charge density because it is a ring. So lambda equals to dq over dl. Now dq equals to dl. The lambda is also equals to the total charge per unit length, that is 2 pi r. We will try to find out the value of dq in terms of dl. So dq will come out q times dl over 2 pi r. Now substitute the value of dq in this formula, that is q times dl over 2 pi r. Now further, now due to the symmetry, this ring, due to the symmetry, if I assume the same element at the value of the ring, and if I assume it's the small charge dq, because the charge is uniformly distributed, let it be again, if I assume the small charge accumulated on this, fine, you'll get the same amount of electric field in this direction, making an angle theta. If I resolve it, so de cos theta horizontal component, de sin theta perpendicular components. Now likewise, due this electric field, if you resolve it, you will get the same thing, d sin theta and d cos theta. So d sin theta, these are perpendicular components and they will be cancelled out because they are equal in magnitude but opposite in direction. So the net electric field will just come out due to the horizontal component, that is d cos theta. So here the perpendicular components will be cancelled out, hence the net electric field will at P will be dx de cos theta. Now d is, substitute the value of de here, and cos theta is based upon hypotenuse. So that is 1 over 4 epsilon q dl over r square 2 pi r. And if I substitute the value of cos theta. Cos theta is base over hypotenuse, that is x over r. Now further, dex equals to 1 over 4 epsilon q dl x over r cube 2 pi r. I simplified. Now total field, to calculate the total field, we have to integrate. So 1 over 4 epsilon q dl x r cube over 2 pi r. Now we have to take out constants. 1 over 4 epsilon q times x over r cube 2 pi r. Now integrate dl. If I integrate dl from 0 to 2 pi r, because dl is the length of the ring, and we have to integrate from 0 to 2 pi r. So dl integration is L, and if I substitute the limit, how is your integration, Iram?
Not good, sir.
Not good. Not good. Look, now integration. If I integrate dx, so the integration of dx will be x. And if I integrate from 0 to 1, then how to do? This is known as upper limit. This is known as lower limit. Now substitute. First, 1. Substitute the value of x. First, you have to substitute 1. Then minus 0. You will get 1. Likewise, now we have to substitute the value 2 pi r minus 0. You will get 2 pi r. Fine. 2 pi r will be cancelled out. So the net electric field will be 1 over 4 epsilon q times x over r cube. Fine. Now substitute the value of r, that is under root x square plus r square by Pythagoras. This is the net electric field due to a ring. There are two cases. If x is 0, it means if we calculate the electric field due to this ring at the center, the electric field will come out to be 0. And if x is much greater than r, that means if we calculate the electric field much more distance than the radius of the ring, then it will come out 1 over 4 epsilon q over x square. This is exactly the same electric field due to a point charge. So we can say this ring behaves like a point charge if the distance is much bigger than the radius of the ring. Is it okay till here? Or how is your integration? If you have problem integration, so I can tell you.
Yes, sir, it's okay.
It's okay.
Yeah.
Shall I teach you integration?
No, this topic is clear.
Okay, fine. Okay, could you let me know how will you do the first one? There is no need to do in notebook now, but could you let me know how to do it? Iram, how will you approach this question? I'm just asking.
Yes, just let me see this. So, in this question,
There are two charges are given. Let it be
yeah,
Q1 and Q2. We have to calculate the electric field at the side
P,
of other. Let it be a
yeah,
point here, then point here. How will you calculate it? We have to use superposition. Okay.
okay, yeah.